Okay guys, so today I just want to give you a feel for all those fundamental identities that we went through last Wednesday, the 23rd. Hopefully you were in class to get those because you're going to need them. If you don't have them, make sure that you find them somewhere. We'll see what we can do about getting them posted, but you really should be in class. Check with your friends, maybe they'll help you out. How do we use all these identities? Okay. Well, one of the things that we can do is we can use those identities to evaluate a function. So for example, let's say that we have the secant of mu is equal to negative 3/2. Okay. And we know that the tangent of mu is greater than 0. Okay, and let's say we want to find all 6 trig functions. So guys, you've actually already done this before, right? We know that the secant is the inverse of the cosine, so the cosine would be pretty easy. It's just simply negative 2 over 3. Okay. Now, this is a little bit of a different way to work through this, okay? What do we know? One of our identities says that sine squared plus cosine squared equals 1, right? Well, let's use this identity, knowing that sine squared is equal to 1 minus the cosine squared. So since we already know what the cosine is, let's go ahead and solve that. So we have sine squared equals 1 minus negative 2/3 squared. Okay, so that gives me 1 minus 4/9. Okay, so that equals 5/9. Okay, or in other words, the sine is equal to the square root of 5 over 3. If you have any questions on how I'm coming up with that, it's just math. That's all it is, okay? All right. So now we have the sine and the cosine and the secant. Well, the cosecant is going to be 1 over the sine, so that's going to be 3 root 5 over 5. Okay? And then how do I find the tangent? Okay? Well, the tangent is just simply the sine divided by the cosine, right? Okay, so my tangent is just simply going to be negative root 5 over 3 divided by that cosine that we found of negative 2/3, which ends up being root 5 over 2. Notice the tangent was supposed to be positive, right? And it is. Okay, so then what is my cotangent going to be? Well, that's simply the inverse of that, which becomes 2 root 5 over 5. Okay, so there's a way of using a different identity in order to figure out exactly what you're doing. Okay. Now, something else that we're going to do is we're going to be simplifying some of these. Okay, so we want to take a look at this, and we want to use all those different identities to see what can I do. Well, I have a sine of x here and I have a sine of x here. That tells me that I'm going to be doing some factoring here. So let's do this. Let's do sine of x times cosine squared of x minus 1. Okay. Well, what's cosine and square root of x minus 1? Well, that's kind of something that you already know. And don't forget, we also have our even and odd identities too. Okay? So cosine squared of x minus 1 is simply all it's simply saying it's going to be negative sine of x. Or what we can also do is just let's factor out the negative 1. So we have negative sine of x. And if we factored out a negative 1, that becomes 1 minus cosine squared of x. Okay, so what is 1 minus cosine squared of x? Well, we know that that's sine squared of x, right? Okay, so it's negative sine of x times sine squared of x. Okay. Well, hopefully you understand that that's negative sine cubed of x. Okay? So those are the types of things that we're going to be doing, simplifying expressions. Okay? Now, we also have to do something like factoring these expressions. Okay, these two poorly written equations say secant squared of theta minus 1 and 4 tangent squared of theta plus tangent theta plus, or minus 3. Minus 3. This is a minus right here. Sorry. All right, so let's look at this one. We have secant squared of theta minus 1. Okay? So secant squared minus 1, that is a perfect square. So what can we do? We can say secant of theta minus 1 times secant of theta plus 1. And that one's factored. Okay? So there's that one. What about 4 tangent squared plus tangent minus 3? Well, it's still the same type of factoring that we've done before. This becomes 4 tangent, and this becomes tangent. We have our 3 here, so the 3 is going to have to go here, the 1's going to go here, because remember, we want to multiply to get 4 and add to get positive 1. So this is going to be plus, this is going to be a minus. So we have 4 tangent of theta minus 3 times tangent of theta plus 1. I'm going to put my thetas in here. Okay. So there we go. Okay. So that's easy if the factoring has all the same trig functions, right? This one has tangent and tangent, this one has secant. Well, what happens when something different happens? What happens when we have something like this? Okay, so what happens when they aren't the same? I have a cosecant squared here and I have a cotangent here. Okay, well, one of the things that we can do is, wait a minute, I know an expression that has a cosecant and a cotangent in it. Okay, it's one of our identities. Okay, remember one of the identities that we had was what? Hopefully you remember that. Cosecant squared is equal to 1 plus the cotangent squared of x. Okay, so I'm going to replace the cosecant squared of x with 1 plus the cotangent squared of x. So this becomes 1 plus the cotangent squared of x minus the cotangent of x minus 3. And again, I'm just simplifying. So let's combine my like terms. I have cotangent squared of x minus the cotangent of x. Notice I now have only one trig function in here. And then what's 1 minus 3? Well, that's minus 2, right? Now, we just need to factor this, and this is an easy factor, right? We have the cotangent of x, we have the cotangent of x, and we have 2 and we have 1. There's no other choices, right? That's got to be minus, that's got to be plus, and look, we're done. So we can factor it just the same, okay? 2 more examples of the type of stuff that you need to do, okay? All right, So what if we have this? We're going to simplify this one. We have the sine of t plus the cotangent of t times the cosine of t. Okay. I'm going to start off by taking my cotangent and rewriting it in terms of sine and cosine. Okay. So I'm going to leave everything else alone. Sine of t. Okay, if the tangent is the sine over the cosine, then what do I have? Okay. If the tangent is sine over cosine, then this is the cosine of t over the sine of t times the cosine of t. Okay. So what does that do for me? Well, nothing so far, but I can get a common denominator, right? If I get a common denominator, that means I need to multiply this, the left-hand side, the sine, by sine over sine. So if I do that, I get sine squared of t plus cosine times cosine is cosine squared of t all over sine of t, right? So what's sine squared plus cosine squared? Well, sine squared plus cosine squared is just simply 1 over the sine of t. Well, what's 1 over the sine of t? That is the cosecant of t. So this big mess just simplifies down to the cosecant of t. Okay? It's just logical follow through from what you already know. Okay? You've got all these different identities that you can use them. Okay? Last thing we want to do is we need to add some trig expressions. Okay? So let's add the sine of theta over 1 plus the cosine of theta to the cosine of theta over sine of theta. Okay. Once again, guys, in order to do this, you have to do what? You have to have a common denominator. You can't add it without a common denominator. So my common denominator is going to be 1 plus the cosine of theta times the sine of theta. So I know that's my denominator, so I'm going to write it down. 1 plus the cosine of theta times the sine of theta. Well, what do I have to multiply the left-hand side by? Clearly, I have to multiply that by the sine of theta, so that becomes sine squared of theta. What do I have to multiply the other side by? Well, that has to get multiplied by 1 plus the cosine of theta. So cosine times 1 is cosine. And cosine times cosine is cosine squared theta. Okay. Well, this is addition. Addition's commutative. I see sine squared plus cosine squared. I can replace that by 1, right? So that gives me 1 plus the cosine of theta divided by 1 plus the cosine of theta times the sine of theta. Hey, what can I do with my 1 plus the cosine of thetas? That can go away, so I all of a sudden have 1 over the sine of theta. Well, what's 1 over the sine of theta? Once again, cosecant of theta. Your algebra rules will come in very, very handy here, guys. You need to know your algebra rules. All right? So, with that being said, those are some examples of the things that we're going to be doing. I'm going to give you an assignment as well, so I want you to try some of these problems. All right, have a great day, guys.